This class we discuss about substitution theorem. This theorem states that any branch of network can be replaced by a different branch as long as its potential and current remain unchanged. When the original branch is passive, either a voltage source or current source is generally used for the substituted branch. This theorem is applicable to any network, linear or non-linear, time varying or time invariant. This theorem is applicable both in time domain and in the S domain. This theorem cannot be applied unless solution to the problem is already known. This theorem is useful in analyzing the behavior of the network. We will work out two problems on substitution theorem. The first problem is 4 resistors 1 ohm, 2 ohm, 3 ohm and 4 ohm and one voltage source 25.6 volts are connected as shown in figure. This is A, this is B, this is positive, this is negative. The question is, for the network shown, substitute the branch AB, A voltage source, B a current source. That is the question. So instead of 4 ohm, I have to substitute an independent voltage source or an independent current source. The first step is I have to find the total resistance. Here the 3 ohm resistor and the 4 ohm resistor are connected in series. The 7 ohm resistor is in parallel with the 2 ohm resistor. Therefore, the total resistance is 1 plus 2 into 7 divided by 2 plus 7. That is equal to 2.556 ohms. Once I know the resistance, I can find the current. I is equal to V by R. That is equal to 25.6 divided by 2.556. That is equal to 10 amps. Now I can find the voltage across the 2 ohm resistor. Because the supply voltage is 25.66. The total current is 10 amps. So 10 into 1 is equal to 10 volts. Voltage drop in that 1 ohm resistor is 10 volts. Therefore, voltage across the 2 ohm resistor is 25.6 minus 10 volts. That is equal to 15.6 volts. This is 15.6 volts. This is a voltage across the 2 ohm resistor. I can find current flow in the 2 ohm resistor. That is 15.6 divided by 2, that is equal to 7.8 amps. Similarly, I can find what is the current flow in the 7 ohm resistor. That is, these two resistors are in series. In series circuit, current is constant. In parallel circuit, voltage is constant. Therefore, 15.6 divided by 7, that is equal to 2.229 amps. The question is, I have to substitute an independent voltage source. Here the voltage drop in the 4 ohm resistor is 4 into 2.229, that is equal to 8.916 volts. The 3 ohm resistor is 2.229 into 3, that is equal to 6.687. So 8.916 plus 6.687, that is equal to 15.6 volts. Kirchhoff's voltage law is verified. Now I can replace an independent voltage source. This is 8.916, this is plus, this is minus, because it is a resistance, it consumes energy. Therefore, the source current is like this. I verify because there are two loops. The resistance is 3, this resistance is 5. A resistor which is common to loop 1 and loop 2 is 2, this is minus 2, I1, I2, that is equal to 25.6. This is minus 8.916, I1 is equal to 10.015, I2 is equal to 2.223, almost the current is equal. This is 10 amps, this is 2.229, this current is 7.8, 7.8 plus 2.229, that is equal to 10 amps. Kirchhoff's current law is verified. The first part is A is over, I substitute an independent voltage source. I can also substitute an independent current source. The voltage across AB is equal to 8.916. The current is 2.229. So instead of voltage source, I can substitute independent current source. This is a proof of a substitution theorem. Problem number 2. 4 resistors, 4 ohm, 4 ohm, 8 ohm and 4 ohm, one voltage source 48 volts are connected as shown in figure. The question is, substitute an independent voltage source and independent current source in the branch AB. This is A, this is B, this is positive, this is negative. I can calculate the total resistance. Here these two resistors are in series, therefore 4 plus 4 is equal to 8. That 8 ohm resistor is in parallel with the 8 ohm resistor, and the equivalent resistance is 8 into 8 divided by 8 plus 8, that is equal to 4. That 4 ohm resistor is in series with the 4 ohm resistor, therefore total resistance is 4 plus 4, that is equal to 8 ohms. Once I know the total resistance, I can calculate the current. I is equal to V by R, that is 48 divided by 8, that is equal to 6 amps. So current flow in the 4 ohm resistor is 6 amps. I can find what is the voltage drop in the 4 ohm resistor, that is 4 into 6, that is equal to 24 volts. I can find what is the voltage across the 8 ohm resistor, 48 minus 24, that is equal to 24 volts. So I can find what is the current flow in the 8 ohm resistor, 24 by 8, that is equal to 3 amps. Similarly 24 by 8, that is equal to 3 amps. Current towards the junction is 6, current leaving the junction is 3 plus 3 is equal to 6 amps. Kirchhoff's current law is verified. First step, I have to substitute an independent voltage source in the branch AB. Here I know the current 3 amps, the resistance is 4, I can find the voltage drop. 3 into 4, that is equal to 12 volts. Here this 4 ohm resistor, 3 into 4 is equal to 12. 12 plus 12, that is equal to 24. Kirchhoff's voltage law is verified. So here this is a 12 volts. I have substitute an independent voltage source in branch AB. This is 12 volts. This is 4 ohms. This is 8 ohms. This is 4 ohms. Now I can check by a simple matrix method. This is total resistance is 12. This resistance is 12. The resistor which is common to loop 1 and loop 2 is 8. This is minus 8 minus 8. I1 I2, that is equal to 48. This is minus 12. I1 is equal to 6. I2 is equal to 3. This is 3 amps. So 3 plus 3 is equal to 6. Here I can replace the 4 ohm resistor and I substitute the independent voltage source 12 volts. Similarly, I know the voltage across AB is equal to 12. I can substitute the 3 amp current source. Here this is independent current source. With this I conclude my lecture. Thanks for listening.